Okay, we're ready. So thank you. Today we have Mark Lodato from Google, and he'll be talking with us about Salsa and some work that's going on in Toto around attestations and signing. Go ahead, Mark. Thank you.
Hi, thanks a lot, Kay. What I'll be talking about is Salsa and Toto attestations. It's available at github.com/slsa-framework/slsa. I'll paste this into the chat so anyone, or actually maybe Tom, if you could do that. And this presentation is in the presentations folder. So if you want to follow along, you can see it there as well. The agenda is roughly, I prepared about maybe 15-20 minutes, and I assume we'll spend most of the time just discussing. Feel free to interrupt with questions as we go. I'll start by talking about Salsa, which is a proposed supply chain integrity framework that we would like to have adopted as part of OpenSSF. It's based on what we have found useful and what we have done internally within Google for the past about 9 years or so. I am one of the original engineers on the project, and I'm the tech lead. That will be kind of motivation for why we talk about the attestation work, which is going on under in Toto enhancement, or ITE numbers 5 and 6. And attestations are extensible authenticated metadata about software artifacts. And I'll talk about why that extensible notion is important. And then finally, we can talk about how SPDX fits into this framework. Is there a question? Okay. So to kind of frame the problem, you could model a supply chain as roughly having these steps. A human developer writes some sort of source code into some source repository, some sort of source code management system. For example, it could be GitHub, but there's many other options. They then build that source code and transform that into a new artifact that's called we call a package for lack of a better word. This could be, for example, it could be as simple as zipping a bunch of files into a zip file. It could be compiling. It could be making a VM image. It could be making a Docker image. It doesn't actually matter what that is, but it's just transforming some input bits to some output bits. And the build process sucks in a source and some dependencies. Those dependencies themselves are either sources or packages as well. And each of those dependencies have their own dependencies and so on. And it's actually a very big, both a broad and deep chain. And finally, the package gets used somewhere. So when we think about what are the threats on an attacker ultimately wants to target that box all the way on the right. They want to attack the user who is using some sort of package. And basically every node and edge in this graph is a potential risk. Someone could submit bad code, starting on the left labeled A, someone could submit bad code. The repo itself could be compromised. Someone could feed in bad code to the official CI/CD system. The CI/CD system itself could get compromised. You could compromise a dependency. You could bypass CI/CD altogether and just, if you have the right credentials, you could just upload a package directly, say to like PyPy or Maven or Docker Hub or something like that. You could compromise the package manager. And finally, even if all of that went fine, if the attacker can trick a user into using a bad package, then all of that was for naught.
Quick question.
Yeah.
So over on the use side, you also could have runtime dependencies where you're dynamically linking in or using, some service. So there's, I think, 2 more attack points over there.
Yeah, that's a good point. I didn't draw it just to keep this diagram somewhat simple. You could think of it as the way actually we're thinking about it within Google is there is some original code that gets used. Often there's also configuration that gets used, and then some dynamic resources that get used. Each of them have exactly the same picture. They just kind of how they are used are different.
Well, the only reason I pointed out is when we get to what is in a software bill of material, some people forget to include the things that the deployed software will use that wasn't in the deployment package.
Yeah. Yeah, exactly. Yeah, it's a different, the techniques that you use to protect that might be different, but yeah, I agree with you. That's kind of still in scope.
I think what Bob's referring to is things like living off the land attacks, right, Bob?
Yeah, but we're good. It's in scope.
Thanks.
So what we're proposing, and we're proposing this through the Open Source Security Foundation, OpenSSF, is a framework called Supply Chain Levels for Software Artifacts, pronounced SALSA, SLSA. Again, it's based on what is work for Google internally. The internal name is called Binary Authorization for Borg. There's a white paper if you care to search for it. The main principles we have are that all changes are auditable and non-unilateral. And by non-unilateral, also called two-party control. And that's throughout the whole stack, not just the code itself, but the build system, the deploy system, the source system, et cetera. The main we have a table listing like what the detailed requirements are, and we still have to flesh out exactly what the requirements are. But the high level takeaway is that there's verified provenance or pedigree from the built artifact back to the sources and dependencies. There's some isolation and hermeticity of builds, and in general, making the builds trustworthy somehow. Two-party review and logging for all changes, and enforcement of policies. And I'll talk about the policies in a second. We use numeric levels to mark progress towards that end goal because it's actually very expensive and very time-consuming and difficult to do this. It takes a lot of time, and it changes. You know, where we're at as a software industry is not here for sure, and so it's important to have intermediate milestones to mark progress along the way. It also allows us to have a standard way to communicate supply chain risk. Everyone kind of easily gets that 2 is better than 1 and 3 is better than 2, without having to talk about all this dozen or so detailed requirements. To show kind of what we're thinking about what a policy would look like, this is based on what we have found useful internally. Oh, sorry, was there a question?
Yeah, there was Dick Brooks had a hand up.
Thank you, Kay. Yeah, Mark, I've been reading this material this morning. This is very encouraging. Just could you go back to the previous slide? So what I found is there's actually an SA0 level that you may want to think about adding to this as well, just for completeness, because I see you have the 1, 2, and 3, but there's several references to SA0 as well.
I see. Yeah, basically it would be not that. Yeah. Okay. Thanks. I'll take a note.
You're welcome.
Any other questions, by the way? Sorry, I can't see if hands up because I'm on another tab.
I don't see any more.
Thanks, Kate.
To kind of give a gist of what type of policies we're talking about, we envision something looking something like this. You would say that a particular package, in this case, the Docker Hub curl image, which is the official curl Docker image, is intended to be Salsa level 3, and it's expected to be built by GitHub Actions and come from the top level source that defines like the recipe is in GitHub. It's curl/curl Docker. And the reason why we want this type of policy is because users have some sort of trust in the Git repo. Maybe that's where code review happens. You do scans. You just kind of, we accept that that's what the source is, and we want to extend the trust in the source all the way to the built package. And by having a policy around that, I as a consumer can have some confidence that that's not going to change. And even if someone on the curl team decides to try to deploy something different, the policy won't let them do that. And so all this is kind of a motivation for why we need attestations, because attestations allow us to express the metadata that these policies consume. So an in-toto attestation, which is currently proposed and not yet accepted within in-toto, so we still have room to make some changes, is that it is signed metadata about a software artifact. We propose 3 distinct layers representing the 3 steps for verifying an attestation. The envelope, which establishes the authentication, meaning who made the statement. The statement layer itself, which has a subject, it binds the attestation to a particular software artifact or group of software artifacts. And then the predicate inside the statement is an arbitrary typed metadata. It could be anything. Anyone could create a new predicate type. And again, our focus is on how do we make this easy to both author and consume within policy. Author from like CI/CD systems or people generating these, and then consume by policy engines. So I'll go through what those 3 layers look like right now. And I also want to point out that these are independent. We could theoretically just swap out the envelope with a different envelope, and the statement and predicate would still apply. And the same is true for each of the layers. Was there a question?
Mark.
Yeah.
Yeah. So in our 3T SBOM discussions, and at least for Microsoft, we're interested in having a very general solution to supply chain attestations. So it's not just software. We want a common solution across software, hardware, machine learning data, IoT devices. Is there anything that is in what you're proposing for Salsa, other than the name, because it has software in it, that is specific to software? Could it be generalized?
I don't know how you would do hardware. I don't know what that even means, so I haven't really thought about that. All the other things like firmware or data are really just bits, and this is really just about data. It's the intended use case is software, but it really could be anything that has a hash. Sorry, did someone want to say something?
Yeah, I wanted to add that part of the research I'm doing is on this space, on like the cyber-physical supply chain, and I don't think anything suggested here precludes figuring out like this problem. I just think that it's still a little nebulous on what are the specifics in there, but I don't think there's anything here that will stop us from doing something along those lines.
Yeah, the main interest, and I'll mention it when we get to the subject area, is that the subject is something that is immutable, so that way it stays true over time. I think that's the main criteria. If we could fit other things into that model, I don't see why it wouldn't work.
Right. So, I mean, as a thought exercise, we could replace the hash with like a physically unclonable function or something like that, just as an identifier for a specific combination of transistors. And then the semantics would still map to this sort of like supply chain graph attestation model.
Yeah.
Yeah, we had another comment along those lines in the chat. Comment there was, doesn't feel like this couldn't work for hardware as long as we have something that maps to a hash. So.
Yeah.
Yeah. It doesn't feel like that this would exclude anything related to hardware. So which is great. So.
Great.
Okay.
So I'll talk about these 3 layers, and just to kind of give an idea of what we're actually talking about here. So the envelope that is currently proposed in in-toto enhancement number 5 is to use the signing. It still needs a name. The as yet unnamed signing specification at this particular GitHub repo. That's kind of like a dumbed down version of JWS. It's a very simple signing, authentication scheme. And the main gist is that you have a type and a payload, and then a signature over some serialization of that type and the payload. I'll talk about why we have the type. Well, I guess I could just mention it now. The reason why we don't just sign the payload directly is for type confusion attacks. I have a hypothetical kind of proof of concept attack where if you assign just a raw CBOR file, you could get it interpreted as a protobuf, for example, which does affect SBOMs in our particular use case. The main kind of thing that this has going over something like JWS is that the protocol is independent from the encoding. So the way that you could take this wrapper, if you don't like JSON and you want to use protobuf or CBOR or whatever else, you could split these three things and then the signature will still pass. Versus something like JWS, you have to keep that exact same bit for bit identical input, or else the signature might be invalid if you don't kind of recanonicalize it the right way. The middle layer is what we're calling a statement, which is a subject plus a predicate based on natural language, the terminology in natural language. Sorry, I didn't update the slide to not have this thing be hidden. Right now, the subject is a cryptographic hash of the contents of the artifact. We have an open issue to be able to identify things that cannot use a cryptographic hash. For example, a subversion repo has no hash. A particular revision in subversion just has like a URI. We'll have to figure out how that works, but we really want to be careful about how we do that because hashes have really nice property that you know for sure it's immutable. Versus when you start to have more complex matching on the subject, the semantics get a lot more confusing. And the name is just to disambiguate between multiple artifacts. If you're talking, you might have a subject that is, for example, one type of predicate is a provenance, which is like how you built something. And so you might have multiple output artifacts in that same process. So you might list them all in a single attestation, like in curl's example, when they build their source artifacts, they have a zip and a tar BZ2 and a tar GZ and a tar XZ, and they could all be listed here. And then the predicate type, the predicate is a combination of a type identifier, for which we're using a URI, which is really just an opaque string, but it's namespace. It has nice properties that it's namespaced. And then the predicate could be any arbitrary JSON object. And to give an example of what a predicate might look like, example company might have a test result predicate that they want to do, and maybe they have a passed field, or they might have like a test run indicator or a name of the test or something. They could kind of stuff whatever data they find useful and that they want to kind of pass on. And we usually include a version number to allow for schema changes over time to know how to parse it. The rationale for having why we have these three layers is because when you think about how you will consume these attestations in a policy, there's three distinct steps. One is who made the attestation, and that is what the signature is for. And I think there's kind of widespread agreement that should be a separate layer because crypto is really hard to get right, and so you want to have a standard library for that. The rationale for having a subject be pulled out into a separate layer is that a second step is, does the attestation apply to the artifact in question? And this is really tricky to get right. It's easy to mess up. It's easy to make a mistake. And so we want to have a single implementation of that, like kind of you have a common implementation of that without every predicate having to do it themselves. And also it allows us to have common lookup and storage. So if you think of like a graph, like the supply chain graph, there's multiple artifacts that feed into one another, and each of them have their own attestations, and you could have some scheme for storing and looking them up. And finally, the predicate is all of the business logic. Does the attestation meet the policy? For example, one might say, I was built from this GitHub repo, and the policies could say, like you saw before, the source has to be this GitHub repo. And by having subject be separate from predicate, it allows you to write that business logic independent of the type of artifact. So for example, you can have a Kubernetes policy, and the artifact is, say, the Docker image that's getting loaded. Or you could have a custom one for example, in Google, we have a custom internal cloud called Borg. And that allows us to separate, does the package that we're loading meet the attestation separate from the policy of what we want to do. And in terms of the rationale for IT5 on using a new signing spec versus JWS, because I think JWS is the main contender here. The argument against JWS is that there's many buggy implementations of it. There's a lot of design mistakes in JWS, and there's many ways to shoot yourself in the foot. And so we kind of avoid that by not having so much baggage. Another is that algorithm is required, but is actually a pretty big mistake. You should never, the algorithm should be tied to the key pair. You shouldn't, for example, have one secret key material that's used for, say, both RSA and elliptic curve, or worse, and this is a real attack on JWS, you have a material that's supposed to be used for elliptic curve, but you say it's an HMAC. So then the library thinks it's just a secret. And the finally minor one is it requires JSON, although I don't think that's a huge factor. We also avoid canonicalization for kind of reducing attack surface. And I already talked about why we have authenticated type. My personal opinion is that, first of all, I don't think a multi-signature is a good idea. It's currently actually in the spec, but I don't think we should be using that. I think we should have separate attestations for each purpose. But again, that's just my opinion. That doesn't represent the consensus view. I also don't think the choice of JWS versus signing spec is huge. JWS is the devil you know, and signing spec is the devil you don't. I think we should. I think it's better to pick something and move on than to spend too much time debating between the two. And then finally, and this is my last slide, how this SPDX can fit into here is that we could have a predicate type. I don't know what string you want to use as a predicate type, and some URI to identify it, and then you stick the entire SPDX document inside there. Right now, that's going to duplicate subject because I know there's already an identifier somewhere within SPDX. And so we'll have to kind of, I think for now it's okay if there's just duplicate. But going forward, if this becomes like the standard way of writing SPDX, then you might want to pull it out. But again, this is just a proposal and certainly needs review from, from SPDX folks. So I'll stop there. I'll go back to the agenda slide so we remember what we talked about. Any comments or questions?
Yeah, it looks like we have a hand up from Dick Brooks.
Thank you, Kay. So I have a question that's really based on a recent discovery on the energy industry side, where we found that a supplier of a piece of software turned out to be one party, and the party that signed it was a completely different party, and there was just no way to correlate the two, the signer to the actual provider of the material. In your attestations, do you identify the party who actually is making the attestation, and how do you relate that party to the signature to ensure that it's an authoritative signature? Thanks.
That isn't specified right in the. I think it. I'm not sure I 100% to follow, so I'm going to try to guess. But if I'm not interpreting the question, please let me know. I think a signature just means that an entity that had access to the secret key applied the signature to this payload, right? That's kind of all it means. Any sort of further meaning has to be inferred by the use of that key pair. And so in different predicates, it's going to mean different things. we have a separate, I have actually a backup slide at the end, a separate provenance predicate that says how an artifact was produced. And here we actually do indicate a separate builder ID, separate like who produced the artifact versus the signature indicates like who signed it. Often they're one and the same, but they might be different. So an example might be GitHub might have a single signing key or a key set, but we differentiate between, say, GitHub hosted actions versus I think it's called self-hosted actions. Another might be you might have an identity provider and like a common signing server that has like, and that maybe verifies identity. So you want to stick the identity in the predicate somewhere. So I guess the short answer is I was thinking that any sort of additional identity you'd stick inside the predicate.
And if I can just add on to that, there's some that there would be some to be specified mapping from this identity to the key pairs, such that you know that like this particular key is allowed to be used by this builder ID or vice versa. But I don't think that we know how to do that sort of for the whole supply chain yet.
Thank you, gentlemen. That was very helpful. And I raised this only because this issue came front and center before the energy industry, not last week, but the week before, where a piece of software provided by NIST was signed by a different party than NIST. And it turns out anyone with a valid key could sign that NIST program and it would check out perfectly. So and this has been brought before NERC as an issue, and they've already acknowledged that it is. But that's the kind of thing that I think you may want to consider, is to make sure that the materials that are in the attestation are there's a direct and tamper-proof link to the actual signer who is authorized to do it. Yeah, but I think Tom, you answered that question. Thank you.
Okay, we have another question from Hank.
So hi, thanks, Kay. Yeah, actually, it's at least two topics I would like to ask about. One of them isn't going to the attestation things. Maybe I will do the second, and the first item is more on the use of the signing mechanism. So what I heard in the end was let's just pick one method and then move on. So, and what I see is the proposal of the signing spec GitHub project. And actually, and thanks to Santiago for that, I was aware of that signing spec reference before. I looked into in Toto. I had some conversation about that and went out and tried to get an opinion about this, because I'm not a cryptologist and I can only well take in the idea that JWS is somehow broken, although I was not aware of something else and the ALK null cipher problem that was just a design curiosity, I would say. So I can see that some implementations might have been problematic, but that's a choice of implementation problem. So when I go out and was trying to get feedback on the signing spec, it was a mystery to basically all people I spoke to, and that's more on the IoT, embedded systems, deployed cloud stuff. Why something that has not received any security, and I'm not citing security analysts from experts that are known, or is widely implemented and used, or actively maintained, or as third is standardized, is to be preferred over JWS, which could be precisely profiled. And you're basically saying it is kind of very similar. So why not profile JWS and make it interoperable in format, and then get all the people that are using that on board, but then tweak it in a way that is just not interoperable. And it's also new and not vetted and not so standardized over years in an open forum such as JWS has been.
Yeah,
I don't know what reason is. Sorry.
Yeah, I mean, to be honest, I'm kind of sympathetic to both sides. I'm okay with whatever the community, like the in-toto community, decides to do. I think we pick this just to make a decision and to move on. I think what you're describing of like make a non-interoperable thing is effectively what we have, which is like, you know, it's either JWS or it's not JWS, right? Like if you make some change, then it's no longer JWS. Yeah, I guess I don't really know if I have a good answer to that. I think what you bring up is a good.
I wanted to make a distinction though.
Okay.
I think the problem was not the implementations. It was being compliant with the specification made this two big vulnerabilities in your implementation. Like the specification required you, it was a must to support these two types of ciphers that essentially opened the door for issues. And I'm also sympathetic to both stances, but at the same time, that's why I think there's these two proposals, basically signing spec and this subset of what we have here as a recommendation. Another element of IT6 is that it actually dissociated in toto from the signature wrapper itself. So we can essentially have these two conversations at separate at separate cadences if we think that that's worthwhile.
Let me. We have a couple of other hands up, and so I want to make sure we're getting a range of comments. Hank, we'll come back to your second question a little later, if that's okay.
That's fine.
Steve, I think you were next. Steve Lasker.
Yeah, thanks, Mark. So you mentioned something about multiple signatures, and I was trying to understand the comment better, because at first I thought you were saying don't believe in multiple signatures, but then you were referring to some attestation related to it.
Yeah, and so maybe I think it was perhaps a mistake to even say this at all. I only bring this up because one of the things that's proposed is JWS compact signatures, what JWT uses, which only supports a single signature. That has other issues as well, which we could get into if you want other reasons why I don't particularly like that. But I noticed in the doc, the integrity doc, I'm sorry, I don't remember the name of it, that Kay shared right before this meeting, that it mentioned there's a use case around having like a single, in our terminology, statement that has multiple signatures attached to it. So in our envelope here, it's an array and having multiple things here. Like I think, for example, Tough uses this currently. Again, this is just my personal opinion. I would suggest that just opens up complexity in the attack surface. That, for example, there's some implementations of JWS that verify any of them, but just return the identity of the first one. And so there's kind of like a lot of mistakes that you can make. And I think if you have a case where you sign, like let's say one entity produces an SBOM and then another entity verifies that it's true or corroborates it, I think you can make that corroboration a separate attestation rather than just attaching a raw signature with some implicit predicate.
Okay, so your comment is more about multiple signatures at a time. So in other words, I'm signing it, but when I sign it, it needs multiple signatures, as opposed, there's another workflow model that we've seen with customers where some entity signs it initially, and it gets propagated into their environment. They want to put their signature on it to stamp that they've approved it for their environment. And then it further down, what they do within the system is they don't trust any of the external signatures. They only trust their internal signature. So I'm hearing that's a different thing than what you're talking about, is the initial entity has multiple signatures on it.
No. It's
Steve. I was just going to say it's just saying, and we've discussed this in the SBOM world as well, that every person who sees or touches or verifies or performs a scan or even says, yep, we're ready to release it. At every stage, there's a separate attestation, and it gets signed at that attestation. So it's just a different, like the use case is there. We're just solving in a different way, which is that there's, instead of using multiple signatures, you'd have multiple attestations, and each would have its own signature. Does that make sense?
I think the difference I'm referring to is, are they independent and not independent signatures that are verifiable? And what I'm getting is, when you move stuff from environment to environment outside of a company that initially created it, then you basically are letting that company decide what they want to validate inside of their environment. The importing workflow might very well validate the external signature. Even for Microsoft software, we tell customers, trust our signature to pull stuff in, but then you should copy it into your environment. And then within their environment, they put their own signature on, and then they can validate based on that. This way, they're not subject to external things. It's no different than when you go to the airport, you go to TSA, you show them your passport, you show them your driver's license, they stamp it. And then inside, they make sure that you have the TSA stamp. They don't really reevaluate your passport or driver's license per se. Obviously, it's a pattern, not an exact science.
Right. So that scenario, we want to solve that scenario. It's just, do we solve it using multiple signatures on one attestation, or do we have a new attestation that gets signed at each point? And I tend to agree with Mark, or I do agree with Mark. It's cleaner if we have a new attestation each time.
Yeah, that's what I'm confirming up here, is that they're independent. They're not like there isn't a collection of signatures in a single document. That part I completely agree with.
Okay, we have a couple more. Antoine, you had your hand up a while ago, and then it went away, and then it came back.
Yes, sorry. So I have kind of a lot of comments about the envelope format, but let me start probably with the biggest issue. So one thing that is very obvious is that the goal of making the protocol independent from the encoding means that there is basically no authentic way to select the verification key to use if you have a verifier that supports multiple keys. So I think trying to avoid, so that's a kind of a big difference with JWS, where you have many mechanisms for doing key selection. You can use kind of a X509 certificate chain, or you can use thumbprint, you can use key identifier. And in all cases, regardless of which one you use, its integrity is guaranteed by the verification of the signature, which is not the case with the format that you are proposing here.
Sorry, I don't quite understand. I omitted it from the slide, but there is some sort of key identifier notion.
Sure, but it will be part of the signatures field, right? It's not part of the payload type.
Correct.
And so most importantly, it's completely erased. If you think of this as a presentation language, it's completely erased during the verification of the signature, which means that some of the attacks that you are mentioning, like confusion between HMAC and RSA key, it actually becomes possible with this format.
I don't think you can make that claim from what was presented here.
Okay, so let's say you have a verifier, and it has one RSA key and it has one HMAC secret.
Right, so if you see here, there is no algorithm identifier because that's on another payload. In the same way that in X509, you will have things living on the higher hierarchy keys that will provide you with information as to whether to trust this key or not another key. This is why you can't make this claim from what you're looking at the slides here.
So I think then it becomes a usability problem. So with the envelope format that you are proposing, it seems very hard to implement a self-contained validation that will select the correct key, because you may just not have enough information.
Sorry, I don't follow that at all. Maybe, yeah, I don't know if maybe this is getting a bit detailed for this discussion.
Yeah, maybe we want that as an offline conversation.
Yeah, let's move it to an offline conversation. But I think by cutting too much, it's actually getting. Okay, so let's follow up online.
How? What's the best way to do that? So we had this is kind of Santiago and Mark. Do we want questions like that to come in through GitHub issues on the Intoto IT repository, or just an email?
I don't know if you have a preference, Santiago. Either works for me. Like for example, the GitHub repo is, I just posted in the chat. If you're comfortable doing it in the chat, we could do it as an issue. That would be okay. I'm okay with email. I don't know if you have a preference, Santiago, for how these.
I think it all works. There's a couple of places in which we could I think there's different questions that should arrive to different places. I5 again, it tries to dissociate the signature wrapper from this Intoto specification proper. So some of these questions about which are the recommended wrappers can definitely fit there. Some others may just fit on the signing spec. If there's issues with the specific signing spec recommendations, then I think those could fit there. I don't know, what do you think?
Yeah, there's also a GitHub issue, which I'll paste in the chat, about considering using JWS. And I think Kay had emailed it before, but I'll paste it in the chat now in case you're interested. If you want to make an argument for JWS to be used by Intoto.
Okay. All right, so we'll move that one offline. Jay Stokes, you've had your hand up for a while.
Yeah, hi, thank you for the talk. Regarding the JWS attacks, is that public? So if anybody written that up in an academic paper, and if not, can you put it, if so, can you put it in the chat?
Sure.
Thank you.
Okay, let's do a quick time check. So we have about 10 minutes remaining. One question is for the group of people that are part of the SBOM Integrity subgroup. I'm thinking it could make sense to have a continuation of this discussion in our meeting next week. And so I thought I'd gauge if that's interesting to folks. And we can invite as many people who are interested in having further discussion. I think for this group, we might focus on the signing signature and I5. We might also want to, we can take that off. So I'll raise it now, but we can take that offline, and maybe I'll send around an email and get people's feedback on the email.
Okay, this is Dick Brooks. I'd just like to say, I've been going through the Salsa materials, and I really like the concept. I don't think it's really, fully flushed out yet, but I think the ability to perform a provenance check as part of a supply chain risk management process is vitally important. So I see this as useful work, so just want to weigh in on that. Thanks.
Great. And Mark, for people who are interested in Salsa, I know there's a GitHub repo for that, so that's a place that people can participate. You mentioned that it'll be part of OpenSSF. I think there was discussion about it being in the digital identity attestation working group. So the question is, what's the forum for, or is there a forum? How would you like feedback on the Salsa proposal?
Yeah, if on the GitHub repo, which again I'll paste in chat. Here, where's the chat? For anyone who didn't see it, we at the top, I think we list ways to comment. GitHub issues, email. We have a mailing list. We also have a feedback form. Any of those are fine by us. We do welcome feedback, and we know that it is not fully specified, and it is not going to meet all requirements. And like, there's, I'm sure, like Google specific things that like work for us but won't work for other organizations. And so we do want to fix those and kind of evolve this to make this something that actually works for people. Okay. Also, I think like one kind of meta comment. I think what I'd like to kind of the big message I want to promote here is the specific choice of like the envelope we could debate. I think that's fine, and to have what is I think a kind of novel piece that we're proposing is the notion of a distinct subject layer with a pulled out, statement layer with a pulled out subject. And that I think is probably something that takes a little bit more thought and like whether it fits into the SBOM world. But it's something I'd like kind of opinions on and consideration for as well.
Yeah, and we might, I know William Bartholomew is on this call as well. So we might want to have some further discussion with William on that. I know Hank had a second question, and he's been waiting patiently, and we do have a few minutes left, so so maybe we can go to that. That was about the subject and predicate, I think.
Exactly. So so maybe this is, of course, this does not fit into the time frame here, but I think we should definitely join in another meeting discussing a little bit what actually sets apart the claims that are subjects and predicates here. Which sets them aside, which up-levels them to attestation, what you call an attestation here. So what I see is that you sign this and you want to put trust in the assertions to some extent, but what I absolutely do not really yet understand is how that trust is founded, what it is founded in, and what's the trust assumption, the trust model here that makes that evidence about the trustworthiness of the assertion effectively.
Yeah, maybe I'll try to just like see if I interpret. Are you effectively saying what gives you trust in the public key? Like what is the trust? Kind of?
Yeah, so exactly. So the public key has some meaning to it. For example, I want to trust that public key or that trust anchor that is associated with it to some extent.
Yeah. So that is certainly a problem to be solved, and we don't yet have a concrete model for how this would work for like open source in general. Within an organization, we're doing this within Google. We do have some well-known trust model of like, we know we have a build system that we trust, and we have some well-known way of where those public keys are stored. And so within like a closed ecosystem, it's solvable. And already, if you get to there, that's I think a win, because you're at least having tools that are working for smaller problems. There's an open problem of like, how do you know what is GitHub Actions public key, or Circle CI's public key, or Google Cloud Build's public key, or whatever, or GitLab or whatever. That I think, for specific cases, if there's a small list, you could just kind of hard code it or something like that, and that is an okay way to proceed when the world is small. For a bigger model, that's kind of to be determined.
Yeah, so that's exactly my point, because to some extent, the signature here and the public key just boils down to a proof of possession. I have a private key, I signed this. But it might lack all the trustworthiness meaning you want. So you can trust that statement only because a key that was used to sign is in possession doesn't mean that the information is in any way useful to your means. So, and that is that attestation. Attestation tells you, the remote attestation in this case tells you, yes, trust this source, is endorsed by an outside entity, is certified, it cannot lie to you under certain circumstances. And I think that's the whole domain that is excluded a little bit, in which attestation a little bit could promise here, doesn't it?
I think it's really, and so first of all, sorry for the confusion between remote attestation and software attestation. There's really no other good word to use. That's why we use attestation. I think it's really the same problem though, because when you say a hardware remote attestation did this thing, it still boils down to a public key possession of a private key, right? It's just that the private key is like embedded in the hardware or something like that. But all of it is a signature by this private key implies something. You believe it for some reason. If an organization like Microsoft, say, did this, like for example, signing the Windows image, you trust that the organization is doing the right thing and they have sufficient controls in place, or maybe not you. One would trust, like most people do, that they're doing the right thing and they have controls in place. And so you could do things to reduce the amount that you have to trust that party by having additional things like remote attestation or whatever, but still it's kind of like turtles all the way down of like, how do you trust that key? Well, how do you trust that key?
Yeah, there are solutions out there that exactly tackle that termination of the turtles that are infinitely going downwards, downstairs to some extent. But I don't know if you want that here. So that might be something we have to discuss in an additional meeting. So where do we stop here? What is our semantical meaning of all this? And what do we not promise, I think?
I will say that on my very personal take, I think there's space for remote attestation within this model. And I would love if we were able to embed this sort of like RATS, sorry for the word, it's not a certificate, but this sort of like RATS attestation or RAT certification over a particular like host or machine, and use that as part of like a bigger attestation over, say, a build process. Something that I would love to have is even say like a TPM measured boot record inside of an attestation of a build process, so that you can know what's exactly on the stack, and you can build this sort of software artifact hypergraph to like essentially authenticate all of the bits that came into a specific build process. So I think there's a lot of space for interplay between these two, and I think we still haven't settled on what the specific semantics are and how these two things will all collaborate together. But I think we can make it work.
All right.
Okay.
We
Scope, sorry.
That's okay. Thanks, Hank. Thanks, Mark. Thanks, everyone. We are at time, so I'm going to go ahead and wrap us up. I'll touch base with Santiago after this meeting, and we can, think about next steps. It seems like we have some good discussion, and maybe we can, have a follow-on meeting, but we can kind of scope it and understand, how what we've been doing in this group fits with other things in Toto, and but we'll get back. Okay. Thanks, everyone. Have a good day. Great discussion. All right.
Really good.
Thanks, everyone. Thanks, Kate.
Okay. Bye.
Thanks, everyone.